Hi, my name is Arifa Delasimo, and I'm making this video today to tell you about a wonderful opportunity you have to invest in yourself and your own future career goals by enrolling in Matthews Tutors. I'm currently a freshman student at Columbia University in the city of New York, an Ivy League institution, where I am studying neuroscience and behavior on the pre-med track. I personally don't believe that I would have had the ability to call myself a Columbia student had it not been for the efforts of Matthews Tutors all those years ago. When I was in high school, I struggled with math, and I knew that I struggled with math. Math filled me with fear, and I wasn't confident doing it. But after just a few sessions with Matthew's tutors, not only was I instilled with the confidence to go forth in whatever math classes I chose to take, but I was able to increase my ACT score by almost 10 points, helping me earn a super score of 35. With those numbers, I was able to get accepted to all 16 colleges I applied to, including but not limited to Cornell University, Georgetown University, Tulane University, Duke University, and the college I currently attend, Columbia University. Matthews Tutors is going to do everything that they can to help you. That's what they did for me. But not only are they going to help you be a better student, they're going to continuously check in on you. I know that I personally received a lot of messages of support from them during my first semester of college, which was one of the hardest semesters I've ever experienced as a student. Matthews made sure that I had the confidence to go forth and pursue my own academic goals, but they also helped me increase the numbers too so that I could get where I wanted to be. And I know that they can do the same thing for you if you give them a chance. Thank you.
Good afternoon, everyone. How are you all doing? I know it's been a while. We have done this. I know it's summer and everyone is going through, having vacations and all of that stuff. By the way, how are you guys enjoying your summer? What have you done for the summer? Just, put a comment in there so I can see what you're doing for this summer. I've had a really good summer so far. I've had a really good summer so far, and I hope you all are having a good summer as well. So, so please let me know how things are going for you. Are you guys going on any summer? Have you gone on any vacations or, some people are trying to get ready for school year, at least in Texas where I am. School starts in about, I think, 3 or 4 weeks now for a lot of students. And so there's a ramp up. Everyone is trying to get, their subjects, try to get ready for the school year and all of that good stuff. So let me know how you guys are doing, what you guys do for this summer and all of that good stuff. And let me know how things have been for you. How was your school year and what are you looking forward to in the upcoming school year? I'm looking forward to seeing a lot of students become successful. And one of the math can be a very challenging subject for so many students and sometimes it creates a lot of frustration for parents. And at Math Tutors, what we've done is we have created a program that will make math simple to understand for any type of student so that math stress becomes a thing of the past. And you can actually enjoy going to school and learning about math because it's one of the greatest subjects that I would say God has ever created. So let's go ahead and get started. So today what we're going to do is we're going to do a lot of math topics for high schoolers and 8th graders. Some 8th graders are taking high school classes. So for 8th to 12th grade, we're going to have some Algebra 1, we're going to have some Algebra 2, and we're going to have some puzzles, mixed there in between. And so let's get ready to have a good time. I'm going to put some questions out there, give you an opportunity to answer them and then I'll show you some of the best methods that we believe will get you a consistently correct answer when you have this type of problems in the future. So let's go ahead and get started. So we're going to solve for x. We're going to solve this inequality here. I know for some of you in high school, even for 8th graders, this is if you're in a pre-AP track or APGT, I think that's what it's called around here. So if you're pre-AP or in Algebra 1, these are some of the topics that you probably have, you're probably familiar with. So we're going to try to answer these questions together. This is inequalities with absolute, so these are called absolute value inequalities. So go ahead and take a stab at it. And if you have any comments, let me see them. I'll be happy to see how you're doing with this. It's possible, you know, you've had a long summer and you've forgotten everything. So this is your opportunity to get back in the groove. Some of those things that you've forgotten, this will be an opportunity for us to try to start reminding you of those topics and how to approach your math so that when you go back to school, it's going to be an enjoyable time. So let's see if there are any comments on YouTube. We're live on YouTube. We're also live on Facebook. We're live on all our Facebook pages and our Facebook group as well. And we're on our YouTube channel. So if you post anything, we'll be happy to, you know, interact with you that way as well. Okay, so let's go ahead and take a look at how to solve this question. So there are two methods that are commonly used. One method is, so let's start off by writing the question. So we have 2x minus 7 is less than or equal to 11. So the first method we can use here is to have negative 11 less than equal to 2x minus 7 less than equal to 11. This is probably the shortest way to do it. So what you're going to now do is solve this as if you're solving an equation. So we're going to, first step we're going to take here is we're going to add 7 to every side of the inequality. So we now have negative 11 plus 7. We have negative 4 less than equal to 2x less than equal to 18. Now that we have 2x here, we have to isolate the x, so and that's by dividing this by 2. So we're going to divide this by 2 as well. Divide this by 2. So we have negative 2 less than equal to x less than equal to 9. So I believe this is the most straightforward way to go about it. But then there are some alternate methods that you could use. They're not wrong, they just take more time. So the alternate method here is realizing that absolute value means that you have a positive and a negative. The value in there could be positive or negative. So what that means is you could have positive, and then we have 2x minus 7 is less than equal to 11. We could also have, let me put that right here, negative, and then we have 2x minus 7 is less than equal to 11. So now we're going to solve each of these, and you'll see why this first method is probably the fastest way to do it. So we have 2x minus 7 is less than equal to 11. So we add 7 to both sides here, and we have 2x is less than equal to 18. We divide by 2, and then we have x less than equal to 9. So you can see we got this part of the inequality. So let's see if we're going to get exactly this same thing here. So we have distribute the negative into the parentheses. We have negative 2x plus 7 less than equal to 11. So we subtract 7 from both sides. And then we have negative 2x is less than equal to 4. So now we have to isolate x. We're going to divide by negative 2. And we have x, we have negative 2 here. And then we have to change this inequality to the opposite. So it's going to be greater than equal to negative 2. So if x is greater than equal to negative 2, that means that negative 2 is less than equal to x. So that's how we get this part of the inequality. So you can see these two methods are fine. They work all the time, but I will say this probably gets you to your answer a lot faster. So I would recommend you use this approach over this, especially if you're under test conditions and you're stressed out. Okay, so let me know if there are any questions. Let me know which of these methods you prefer. I think they're both good. And so we'll go to the next question as we await your comments. So we're currently running a summer program, and it's ending for some students next week, and for students in the East Coast, we're going to extend it because they go back to school in September, and a lot of them have gone on vacation, and they probably want to spend the last few months or the last few weeks of the holiday just trying to get into the mindset of getting ready for school. And so this is one of the topics that we covered in our Algebra 2 class this week, and I think it'll be a good one to just to kind of refresh our memory with. So this is composing functions. And so let's go ahead and take a look at this. I'll give you a few minutes to try it out, and then we'll take a look at it together. If you're not sure what to do, put that in the comment. It's very possible that you just finished geometry and you haven't seen this before. So I'll try as much as possible to go over it in a way that will make you understand. And for those who are already in Algebra 2 going to pre-calculus, also let me know if you've forgotten, and I'll try to make sure that the approach that I'm going to use here will address all of your concerns. Let's see if there are any comments so far. So this one here, the topic is composing functions. Composing functions, or some may call these composition of functions. They all kind of mean the same. Okay, so let's go ahead and try to answer this question together. Whenever you have a situation or a question where you have to compose functions, so let me just spend a few minutes just going over it quickly. So if I have f of g of x, for example, which visually we start off with FOG, so of x rather, FOG of x, f of g of x. So what that simply means is that you're going to compute the function inside of the parentheses first, and then you will use that value as an input to the function out here. So what we're going to do, step one, is find g of 1/3, and then whatever value we get here, we're going to use it as an input. So let's go ahead and do that. So find g of 1/3. So remember that g of x is equal to 1 over x. So g of 1/3 is 1 over 1/3, which is also the same as saying 1 divided by 1/3. And whenever you have division here, we're going to replace that with a multiplication, and we flip the position of the numerator and denominator of the fraction. So that is 3 over 1. So this is going to be 3. So we have g of 1/3 is 3. So what this function now becomes is we're going to look for f of 3, because the value of this function, of the computation of this function, becomes an input to the function on the outside. So now we have f of 3, which is going to be 3 squared minus 3 multiplied by 3 plus 1. So 3 squared is 9, minus 3 multiplied by 3 is negative 9, and then we have plus 1. And then we have to obey the rules of PEMDAS, and fortunately we have the same order of precedence, so we're going to go left to right. 9 minus 9, 0 plus 1, this is equal to 1. So therefore, f of g of 1/3 in this case is going to be equal to 1. So that's how you will do a problem like this. Some may actually just make you do something like f of g of x. Probably get to that in a later video or later lesson. And go to our YouTube channel. Our YouTube channel has, subscribe to our channel. If you're new to the channel, please subscribe to the channel. There are a lot of videos there covering almost every topic that you can think of that you would encounter in your math classes from elementary school. We're looking at grade 1 all the way to about pre-calculus. We're going to be adding some more pre-calculus videos and eventually start putting some calculus videos in there as well. So this should be a good resource. We found so many students find our resources helpful as they go through the school year, and a lot of our students use that as an additional resource when they're working through their school work or getting ready for their exams or finals. So let's go to the next question. The next question is, find the length of the line that joins points -9, 8 and 7, -2. Let's give you some time to think through that. This is distance between points, and this is an algebra 1 question. So algebra 1 is also a geometry type of question, and this is called the distance between points. Distance between points. I would say here, get used to knowing how to come about these formulas. I actually have a video on this showing you exactly how this formula comes about using Pythagoras Theorem. So I will go ahead and I'll actually write the formula for you, because I know a lot of you I know in a lot of school systems, they actually give you a formula sheet. So I'm going to write the formula just to give you a starting point. So the distance between 2 points, let's call this D, is given as the square root of y2 minus y1 squared plus x2 minus x1 squared. Or you can actually do it this way: y1 minus y2 squared plus x1 minus x2 squared. So these two formulas are going to be adequate in trying to get the distance between any 2 points on the coordinate plane. So remember, you can have any of the points be x1, y1 or x2, y2, but you just have to be consistent in the way that you are answering the question. So if you decide to make the first point x1, y1, you have to make the second point x2, y2, and you just stay with the same order. You're going to go y1 minus y2. Because this is you're squaring everything, it probably won't matter which order you go, but I don't want you to develop that bad habit, because if you look at this, you can see that these are some of the components for finding the slope of a line, and I want you to understand that you have to make sure that you're using the same order every time you're dealing with slopes or distance formula. So let's go ahead and answer this question. Let's go ahead and answer this question. So we have y2 minus y1 squared. So I'm going to write out my points. So I have negative 9, 8. I also have 7, negative 2. So what this is going to be, I'm going to have x1, y1 here, and then x2, y2. For me, it doesn't matter which method you use, which of these formulas you use. I am used to this one. I use this more often because it's just the way that I remember it all the time. So I'm going to use this formula. So it's going to be d equal to the square root of y2 is negative 2, y1 is 8. So negative 2 minus 8 squared plus x2 is 7. X1 is negative 9. So this is going to give us square root of negative 10 squared plus 16 squared. So this is going to give us the square root of 100 plus 256, which is going to give us the square root of 356. Now, because you are an advanced math student, you cannot stop here. Any student past middle school or junior high, I consider to be an advanced math student. So you can't stop here. You have to now simplify radicals. How do you go about that? Let's go ahead and draw a prime factor tree. I know some people just draw factor trees, but I prefer to do a prime factor tree because it allows you to be more organized in your thought process. So we have 356. We divide by 2. Because it's an even number, we get 178. We divide this by 2, and we get 89. So 89 is a prime number, so you simply stop there. So what this is going to give us is the square root of 2 multiplied by 2 multiplied by 89, which is the same as the square root of 2 multiplied by 2 multiplied by the square root of 89. So the square root of 2 multiplied by 2 is 2, and then we have the square root of 89. So this is how you would write your answer. If I was a teacher and you have just square root of 356, I'll probably give you maybe 3.5 out of 5 points for it because it just tells me that you haven't gone the extra mile to get to a simplified version of your answer. So this is the best method. You will see that if you actually went y1 minus y2, you get exactly the same, plus x1 minus x2 squared, you get exactly the same result. So let's go ahead and we're going to have a puzzle, our first puzzle for the day. This is going to be our first puzzle for the day. Which one of these figures is least like the other three? I've been very intrigued by this type of problems. I think 2 nights ago I was having an IQ test with the children, and it was so fun doing some IQ tests, and just we had a really nice family time. One of my younger children wanted to do something like that, so we did that, and it just makes you kind of think outside the box. So that's what this problem is there for. Which one of these figures is least like the other three? Let's see what you come up with. Is it A, B, C, or D? And if you don't mind, put your reasoning there. Why do you think your answer is correct? I'd like to see your comments on Facebook. Let's see why you think your answer is correct. It's always nice to see how we think through some of these problems. There are a lot of pitfalls in this question, but I'd like to see if you fall for any of the pitfalls. But the answer is pretty straightforward. Let's if okay. Someone said D. All right, Jaden, that's very interesting. Can you post a comment, explaining why you think D is the correct answer to this problem? Why do you think D is the one that is least like the other three? Okay, I see Anastasia saying C. Okay, let's see your reasoning. Your reason is important. Why do you think C is least like the other three? All right, let's go ahead and try to see if we can come up with something that makes a lot of sense. So if you see here, we have this shape right here. You see that it's almost looking like a Z. This one looks like a Z. This one also looks like a Z. But this is actually a reflected image of the Z. So this is going to be the one that looks least like the other three. There are a few things that could have thrown you off. One of them is seeing that there is a square on this side and a circle on this side. Could have been one thing that throws you off. Okay, let's see Jaden's reasoning. The body is facing the opposite way. Okay, all right. Anastasia's reason is because the square and the circle are different places than the other squares and circle. I knew it. I knew that those were going to be the two possible reasons why a student could be thrown off with this puzzle. There's going to be one more puzzle towards the end, so that one should be exciting. So good contribution from our students, our viewers today. So let's go ahead and go to the next question. Feel free to ask questions. If there's something that's on your mind that you really want me to address, feel free to ask it as well. This is really all about you. I know math can be a challenging subject for so many of you, and one of the things that we are passionate about at Math Tutors is to develop this program that we've used successfully for other students, but apply it to so many other students to help them see math as a more enjoyable subject. And for those who don't ever think they'll enjoy it, at least tolerate it and not cause you any kind of stress or any kind of anxiety, because I've had students that started off with Math Tutors with our organization, and they had a lot of math anxiety. And after working with them for a while, they were able to do away with the anxiety, because sometimes anxiety could just be, it could be some type of fear. Sometimes that causes anxiety, or sometimes you feel unprepared for something and you just don't want to deal with failure. So that brings about anxiety. So what we try to do for our students is give them the confidence that they need to be able to address any kind of math topics that they're dealing with. So we always focus on giving you the best practices, the best approach, repeatable approaches. So we don't want you to come to us, we teach you something, and then when you go to your test, you feel frozen out because you only learn how to answer the type of questions we gave you. We want you to understand the technique behind this question so that you can apply the technique anywhere at any time. So let's go to our next question. All right, this is algebra 1 for sure, and this is multi-step linear equations with fractions. So multi-step equations multi-step equations with fractions. Multi-step equations with fractions. And I will let you work on this for some time, and I'm going to show you a method that I use that works for anybody. And this method will help you, especially if you don't like dealing with fractions. This will make things so simple for you. So let's give it some time, and then we'll see if anyone has some answers. So here we're solving for you, and this is Algebra 1. And I believe for some students that are in some school districts, especially I know in the East Coast, this will be something that 8th and 7th graders will be introduced to. But for sure, every student will see this in Algebra 1. So go ahead and try to answer this question. Let's see what you come up with, and then I will show you the best method that will make this so simple to do. Once I show it to you, you're going to love it. I believe students have an irrational fear of fractions, and because of that, I like to use this method that takes into account that you may have an irrational fear of fractions. So if you have any answers, go ahead and post them. If you're not even sure, I'm sure some students probably thinking, what is this? Like, how am I supposed to do this? So if you have any questions, feel free to post them. If you have any concerns about this, also let me know. For those of you that have friends, siblings, that are in lower grades, tomorrow we're going to tackle most of the lower grade. We're going to have most of the grades, the lower grades. So we're going to be looking more about probably grade 1 or 2 all the way through to grade 7. We're going to try to bring questions that will be more appealing to them, because I know that this probably looks like Greek or French to lower grade students. It's probably, don't let this discourage you. Sometimes you can pick something up from just sitting through this and listening. Math doesn't really change a whole lot as you get into higher grades. The same concepts are there. So let's see. Do we have an answer? Any comments on this? Okay, let me show you my method. We call it the math is simplified approach to math. We try to make math simple. We don't use easy, we use simple. Easy means that you don't have to put any effort. Simple means you're going to put in some effort, but you'll find it a little bit, you'll be able to do it at any time. That's what makes it simple. You can do it continuously. Easy means no effort. We don't believe in that. Math requires effort, it requires time, it requires dedication, it requires commitment. So nothing in math is easy, but it can be simple. So now I'm going to show you the simple method you can use, the simplified method that we typically like to teach our students for this topic. So I'm going to write out the question again. It's just a habit I have. So it's 7 over 4, and then we have 4 plus u equal to negative 2 over 3 plus u. So what I'm going to do here is we're going to come up with a number that is a multiple of 3 and 4. So least common multiple, or if you don't even want to deal with least common multiple, you can just multiply the denominators together. So 4 multiplied by 3, that is 12. So what we're going to do now is multiply everything in this equation by 12. If we multiply everything by 12, we can be sure that we're going to get rid of the fraction and we can just work with integers. So let's go ahead and do this and multiply this by 12. So we'll start off by multiplying 7 over 4 by 12. And this is going to give us, this is 21. And then we'll go ahead and multiply 2 over 3 by 12, and this is going to give you 8. So now we're going to go ahead and change each of these multiples out here. We're going to replace the fractions with these numbers. So this is going to be 21 multiplied by 4 plus u equal to negative 8, and then u multiplied by 12. Remember I said we're multiplying every term. The reason why we're not multiplying each of these by 12 is because this is going to be what affects what we're going to multiply each of these terms in the parentheses by. So we have negative 8 plus 12u. So now you see our fractions are gone. You don't have to worry about fractions anymore. So now we can go ahead and further simplify, knowing that the fractions are completely gone. So this is going to be 84 plus 21u equal to negative 8 plus 12u. And now we can go through the process that we normally go through to solve linear equations. So let's go ahead and let's bring the u on the left side and the integers to the right side. So I'm going to subtract 12u from both sides. And always remember, whenever we are trying to move things around, we're always using the opposite. So if it's plus, we're going to subtract. We're always doing the opposite thing. So we're going to have 84 equal to negative 8 plus 9u. And then we're going to add 8 to both sides. So 84 plus 8 is 92. And then this is equal to 9u. So 9u equal to 92. So we divide both sides by 9. And we have u equal to 92 over 9. In algebra, I don't really care about writing this in mixed number form. This is good enough. If you want to go ahead and convert it to a decimal, which I think is completely unnecessary, but I notice a lot of students love decimals. This is probably going to give you 10.2, and the 2 is going to repeat. Okay, so I think coming up, we're probably going to have some questions that are, I'm going to skip this one and we're going to go to this one. Let's go to our puzzle. Let's go to our next puzzle. After our puzzle, we're going to do some SAT type questions. SAT exam is coming up in a few months. I believe in October. It's going to be the next SAT exam. And so right now we have a SAT course that has started. It started at the beginning of July, and we're going to go all the way till the end of September. And the goal of this is to make sure that we have students prepared for the test in a way that gives them confidence to go up, to go deal with the test. It's a test that sometimes brings stress, and so we're going through a very methodical approach to make sure that students are prepared for the test. This test, I know there's a lot of talk out there about, is it required, is it not required? We'll probably do a webinar soon on why the SAT is still important. So let's talk about this one. What is the missing number here? This is another puzzle for us. What is the missing number out in this pattern? So you have to first establish how these numbers are related to each other and then use that to find the missing number. So don't forget, tomorrow, elementary, middle school or junior high, depends on your state and your school district. Middle school and junior high, roughly the same thing. So elementary and middle school tomorrow, we're going to do it at the same time. We're going to do that at the same time. So what is the missing number here? Let's wait for some comments. 5. Okay. What's your reason for 5? How do you get to 5? It's puzzle time. So we have these shapes here with numbers around them. We have 4 numbers on the outside and 1 number on the inside. We're trying to establish an algorithm for the number inside the shape. So let's go ahead and see what you guys think. Oh, 9 minus 4. Okay, so if it's 9 minus 4, does that mean 7 minus 8 equal to 8? Does that mean 5 minus 5 equal to 6? So remember, the algorithm you come up with should work for all of the other shapes. Okay, let's go ahead and try to come up with the algorithm. So we have 1 and 3 here. We have 1 and 3 here, and then we have 5 and 5. Let's see what possibly could be. Okay, I see 9. How did you get to 9? Curious about that. Good contributions today. I know it's been a while we did this, so everyone is trying to get back into being familiar with this. So we have 9. Okay, someone changed their mind and it's now having 9. So let's see why you think it's 9. It's all about seeing how you're thinking through it. It doesn't matter if you're wrong or right. Okay, so let me show you something here. So let's go ahead and let's try to add each of these. 1 plus 3 is 4. 5 plus 5 is 10. Ooh, 10 minus 4 gives me 6. Could that possibly be true for everything else? 8 plus 7 is 15. 3 plus 4 is 7. Ooh, 15 minus 7, I can get 8 from that. So it looks like we've established an algorithm that works for 2 of them. So what we're going to do here now is 4 plus 9 minus 1 plus 5. 4 plus 9 is 13. 1 plus 5 is 6. So we're going to get 7. So 7 that's going to be the number in the middle here. 7. 5 plus 4. Okay, all right. That's good enough. Okay, let's go to an SAT type question. Oh, wonderful. 7. Taylor, welcome. Welcome on board. Okay, let's go with an SAT type question. So this is going to be for students that have taken Algebra 1. If you haven't taken Algebra 1, this may not. But I think for most students, 8th grade, if you're going to 8th grade, maybe you haven't taken Algebra 1. But if you're in 8th grade already and you're in a pre-AP track, you would have taken Algebra 1. But if you're in 9th grade already, you should have taken Algebra 1. So let's see how you do with this. This is one of the things about the SAT. It is all about aptitude. The topics are not really complicated. It's just the way you think. It's really testing how you think. So everything you need is right here in the question. You don't have to do too much, and your answer is pretty straightforward. So x plus y is equal to 7. X minus y is equal to negative 3. What is the value of 2x minus 2y multiplied by x squared minus y squared. What is the value of x squared minus y squared multiplied by 2x minus 2y? So SAT students, this actually I adapted from a past SAT exam question. So this is real. So let's see what you have. Let's see what you have. This is gonna involve a lot of factoring, but the factoring is not difficult. So let's give it a few more moments and then we'll go ahead and try to answer it together. If you're not even sure what this is, put that in the chat. This doesn't make any sense. This looks foreign. I have never seen anything that looks like this before. But if you feel comfortable or you just forgotten, hey, I've forgotten this, I think I've seen it before, but I don't remember how to do it. And then I'll show you how simple it is. You notice I don't use easy? It's simple. It can be repeated. Easy means you don't have to do work. All right, so let's go ahead and just show you a few things. So we have x plus y equal to 7. We have x minus y equal to -3. So let's deal with 2x minus 2y. 2x minus 2y. So you can see here that if I actually factor this, I get 2 multiplied by x minus y. Then I have x squared minus y squared. This is called the difference of two perfect squares. And what you're going to do here is you're going to have x plus y multiplied by x minus y. So you can now see that 2x minus 2y multiplied by x squared minus y squared is the same as 2x minus y multiplied by x plus y multiplied by x minus y. And now we're going to replace that with the values. So this is going to be 2. X minus y is -3. X plus y is 7. X minus y is -3. And so we're going to get 2 multiplied by -3 multiplied by -3. This is 9 multiplied by 7. So this is going to be 9 multiplied by 7 is 63 multiplied by 2, 126. I know some students would have tried to find the values of x and y using the system. Probably done something like this. X plus y equal to 7, x minus y equal to -3, and then solve for x and y, and then try to plug that into the expression. That is an absolute time waster. So this is a technique on the SAT that I want you always have to look for the fastest, simplest way to get to your answer. Because remember, on the SAT, you have roughly 1 minute to answer any question. You're going to always, I believe there are 2 sections. You're going to have, on the first section, 20 questions, 25 minutes. And 5 of those questions are free response questions. So you can see that you roughly have about 75 seconds per question. So always find a way, and this is where practice comes in. And our SAT summer program, that's what we're trying to do with our students. Show them all different types of questions and how to go about it. And so this is one SAT question. I'm going to pull up another SAT question that I think you'll find interesting, and then that will be our last question for today. And tomorrow we'll have our younger students, younger being elementary and then middle and junior high. So triangle PQR is a right triangle. If sine P is 15 over 17, what is tan R? So let's go ahead and draw a right triangle just so that we can get some we can have a starting point. So right triangle. Okay. So this is P over here, this is Q over here, this is R. Our right angle is at Q. So this is PQR, and sine P is 15 over 17. So we're saying that this is P also over here, this is R also here, because the sine is only on the angles. If you have any questions, feel free to ask. If there are topics that you probably struggled with in the last school year and you want to just get an opportunity to get that addressed before you go back to school, put that in the chat. We'll make sure that the next time we have a live session for your class category, we'll factor those in and probably put in a few of those questions so we get different opportunities to address those topics for you. So this is geometry. This is trigonometric ratios. Trigonometric ratios. SOHCAHTOA, for those that have taken geometry, SOHCAHTOA is what we're testing here. And so we have a few more minutes. We have about 5 more minutes before we finish this live stream. So let's go with sine. So we always start with SOHCAHTOA. It's just a habit. And I would say it's a good habit to form to use SOHCAHTOA whenever you're trying to do trigonometric ratio. So S is for sine, so let's go ahead with that. Sine P is 15 over 17. So what that simply means to us is that sine is the opposite side to the opposite side to the angle divided by the hypotenuse. The hypotenuse is always the longest side of your triangle, of your right triangle, and is the side opposite the right angle. So that means this is going to be 17 over here. This is going to be 15 over here. So sine P is equal to 15, opposite side to the angle, divided by your hypotenuse. And now we need to figure out tan. Tan is tan of R is the opposite side to the angle, which is right here. This is x. So the opposite side to the angle divided by the adjacent side. Adjacent side simply means that that side is, this is the way I explain it usually. The adjacent side is involved in forming that angle. So, and it is the side involved in forming the angle that is not the hypotenuse. So that's what we're going to be looking for. Here, your adjacent side to this angle here is 15. But we need to find the value of x. So now we bring in our Pythagoras theorem. Pythagoras theorem simply states that in a right triangle, the sum of the squares of the legs are the sides that are not the hypotenuse, the sides that do not slant. So the sum of the squares of the legs of the right triangle is equal to the square of the hypotenuse. That is what your Pythagoras theorem is. So a squared plus b squared equal to c squared. And here, a and b, it doesn't matter what you have, which side you use for a and b. I could say this is my a over here, this is my b over here, and this is my c over here. Well, c is going to be, for sure, 17. So what we're going to do here is we're going to say x squared plus 15 squared is equal to 17 squared. Now, see, math is you can apply math in so many interesting ways. What I'm going to do here is I'm actually not going to go figure out what 15 squared is or 17 squared is. I'm going to use a principle called the difference of two squares. the difference of two perfect squares, and here's how it works. A squared minus b squared is a plus b multiplied by a minus b. You can see that I try to stay away from the calculator as much as I can because I think it's important to get your mind occupied, your mind working. If you use a calculator, you might as well just be a robot, just punching a bunch of numbers. So I would go this way. X squared is equal to 17 squared minus 15 squared. So what we're going to do now is apply this difference of two squares. So this is going to be 17 plus 15 multiplied by 17 minus 15, which is equal to 32 multiplied by 2, which is equal to 64. So x squared is 64. Therefore, x is the square root of 64, and that is going to give you 8. So now x is equal to 8 right here. So now let's go ahead and figure out what tan r is going to be. Tan r is the opposite side to the angle, which is 8, divided by the adjacent side to the angle, which is 15. So tan r is 8 over 15. Tan r is going to be 8 over 15. And this is actually a very good question on the SAT. You will see this a lot of times in the free response portion in the section 4, or the section that is the longer section with about 8 free response questions. So your tan r is 8 over 15. Okay, so now that's all. Those are all the questions we have for those are the questions we have for our live session today. I want to remind you that one of the reasons why we're doing this is part of our back to school campaign. We want to get you ready for school again. And as we get closer to back to school, this is an opportunity